This is the next video in a chapter on atoms, molecules, and ions. We are moving on to talking about chemical symbolism, specifically about chemical symbols, isotopes, and chemical formulas. So we talked last time about the different kinds of subatomic particles and about how an atom or an element is defined by how many protons it has. But when it comes down to it, we just can't be writing all that information out every time we want to talk about an atom. So we don't have time to write out the name of an element every time we're trying to talk about it, because they're very long, some of them. And we don't have time to indicate the total number of protons, neutrons, and electron counts every time. It's simply too much writing. So we came up with a faster way to summarize all of the important information about a particular atom. So instead, we use what is called chemical or elemental symbols. And you've probably seen these before, written on paper or in the periodic table. So the symbol for an element might look something like this: C for carbon, or you might have seen Na for sodium. So these 1 or 2 letter combos, those are the chemical symbols. So they can be 1 or 2 letters. The first letter is always capitalized. There may or may not be a second letter, and if there is, the second letter is not capitalized. And so when we list these chemical symbols, we can also list numbers around the top and bottom left and right corners to indicate the total counts of proton, neutron, and electron. So if you see carbon, you might see it written like this. Or maybe you would see a sodium atom written like this. So we'll talk a little bit more about what these different numbers mean. I'm also going to include a made-up element, EL, for element, so we can talk about the generic name for each of these numbers. Not a real element. Okay, so let's talk about these numbers that go along the side. So that we'll start with the number at the bottom left, Z. That's called the atomic number. And if you're using it to do a calculation, it's called Z. So the atomic number is the number of protons that's inside of an atom of this element. And as we know, the number of protons is how we define what element it is. So very important. But the chemical symbol, the letter, also tells us how many protons there are. So technically, we don't have to write it. We don't have to write that in the bottom left corner. So it's often omitted. Okay, so there's our total proton count. So we'll move on to the number in the top left corner, and that is called the mass number, or sometimes it is called A when doing calculations with it. So the mass number represents how heavy an atom is, and as you remember, the only 2 parts that have an appreciable amount of mass are the protons and the neutrons. So the mass number represents the number of protons plus the number of neutrons, which represents the number of particles in the nucleus. There we are. Okay, so that's what this number in the top left corner represents. And then the number in the top right corner is called the atomic charge. And that tells us about how many electrons there are. And I don't think that there's a letter symbol that represents that one. So to find the atomic charge, we take the number of protons or positives, since each proton has one positive charge, and we subtract the number of electrons or negatives, since each electron has one unit, a negative charge. And so this may be a new concept, and that is that there is a charge for a particular atom, and that atom can change, the atomic charge can change without the atom changing. So let's talk a little bit more about charge here. So if you have an atom that is neutral, then it must have equal numbers of protons and neutrons in it. Sorry, protons and electrons, positives and negatives. And that makes sense, right? If we have the same number of positives as we do negatives, then the atom is not going to have a charge. So that's going to be a neutral atom. So that's going to be something with a 0 or nothing in the charge position. But if there is a number in the charge position, that number can be a positive number or a negative number. And if there is a charge, it's called, the atom is called an ion because it has a charge. There we go. So charged atoms, if they have a positive charge, they are called cations. And if they have a negative charge, they are called anions. Good crossword puzzle words. Okay, so cations, those are positive. And if we have positively charged things and we have negatively charged things, then it makes sense to say that the only way to have a cation is if there are more positives than negatives. So cations have a greater number of protons than electrons. And the opposite is true for an anion. So anion is negative. And they have number of protons less than the number of electrons. And if you add the number of positive and negatives together, that will tell you the net charge. Okay, so now we know how to use these three numbers and we know the definitions of these important words. So let's test our skills with an example. So feel free to pause the video and try this on your own before watching me do it. So the example says, how many protons, neutrons, and electrons do these two atoms have? This carbon-64 2 plus, copper, Cu is copper 64 2 plus, and this carbon-12 1 minus. So we've got to find protons, neutrons, and electrons for each. So let's start with the easiest one. The easiest one is going to be the protons. So copper always has the same number of protons, but it's also listed here for your convenience. So our protons is 29. Okay, and then the next easiest thing to find is the neutrons. We know that the mass number, that top left number, that equals the sum of the protons and neutrons. So if we take the mass number of 64 minus the number of protons, 29, that leaves neutrons. So mass number 64 equals 29 protons plus X neutrons. And we can do 24 minus 69. And that should give us 35 neutrons. Okay, this is going to get sloppy, so we're going to start using boxes. So 29 protons for copper, 35 neutrons for copper. And then we need to find number of electrons, and we can find that from the charge, which is that top right number. So number of protons minus number of electrons equals the atomic charge. So our atomic charge is 2 plus, and that equals 29 protons minus X electrons. So we have to move these around, move the X to this side, move the 2 to this side, and we should end up with 27 electrons. There we are. We didn't leave enough space for the other one, so we'll have to do it mentally without doing all of the math the long way. So this is for the copper. Copper 64, 2 plus. So over here, we will do the copper 12, 1 minus. So protons is defined by the element. So this is going to have 6 protons. If we take the mass number 12 minus the number of protons, which is 6, we get 6 neutrons. And if there is a net negative charge, we're going to have one more electron than proton, and 1 more than 6 is going to be 7. 7 electrons. The carbon 12, 1 minus. So if you are given an atom with its mass number and its charge, with or without the atomic number, you can figure out the name of the element and the total number of protons, neutrons, and electrons without having to have them written all the way out. So with our new knowledge, let's revisit our atoms first approach summary and check off what we have completed so far. So we are starting over here with atoms, and we have now learned all about the parts of an atom. So we can check that off. And in the next video, we will talk about elements and their different isotopes.